everyone, welcome back. In this particular video, we will be discussing the problem determine the capacity of the largest container. The problem is saying you are given an array n size which is containing non-negative integers. So array at least having some elements. Each of those elements are positive, that is non-negative, at least greater than equal to 0, where each element represents the height of a line. So each array element will be representing the height of a vertical line. N vertical lines are drawn at points marked 1 to n, as you can see in the image. 1, 2, 3, 4, up till n. N is the array size on the x-axis. Find two lines which together with the x-axis forms a container. Find two lines which together forms a container along with the x-axis, that is the horizontal line. And the container should hold the most amount of water. Assume the width of the lines to be negligible. So we have to assume the water should be as a plane only, or you can say width should be 1. So volume will be length into breadth into 1. So we only have to consider 2D area and not 3D area. That is what it is mentioned in the assumption. We have to assume 2D area. And you have to not slant the container. That is, you cannot basically take any edges or maybe take any diagonals or maybe take any kind of slanting. You have to take vertical or the horizontal line. Horizontal should be the x-axis. Verticals are what is given. And n will be at least 2. It means there will be at least 2 heights given. There will be at least 2 vertical bars given. Input format, as you can clearly see, is a array n size containing n elements. Each element will be positive because height should be positive, and the values corresponding to each of the array elements. So for this sample input 1, 8, 6, and so on, there is one input also given 1, 8, 6, 2, 5, and so on. So let's do what? Let's actually bring the sample input only in what? In the notes. So we are taking a screenshot for the sample input and we will bring the screenshot, and accordingly we will make a diagram and we will see how we can actually form the maximum area container. So there are some bars. Let me make the grid so that we can make the bars easily. Okay. So first grid will be, or first vertical line will be of 1 height. Next vertical line will be, actually let me make it from below. This is 1 height. This is 1, 2, then 3, 4, 5, 6, 7, 8 height. Then next height will be 6. So 1, 2, 3, 4, 5, 6. It will be visible after I will remove the grid, don't worry. And then after 6, it will be 2 height. After 2, it will be 5 height as given in the sample input. So 1, 2, 3, 4, 5 height. Then after 5, it will be 4. Then after 4, it will be again 8. After 8, it will be 3. After 3, it will be 7. This is the sample input. Let me just remove the grid. This is the heights given. And the x-axis is always, you can say, at 0. And let's say I am marking the heights also below. This is 1 height, this is 8 height, this is 6 height, this is 2 height, this is 5 height, this is 4 height, this is 8, this is 3, and this is 7. And we have to form the maximum area container, which according to the answer is 89. Sample output is 89. And what is that area? That area is 7 into 7. We have to actually, not 7 into 7. Yeah, it is 7 into 7, which is the lines 8 and 7. That is first line with 8 height and second line with 7 height. These two heights and the length will be actually the distance between them, and distance between them is 7. So 7 is the length, 7 is the height, area will be 49, and that is what they are saying is the maximum. Why I can't take 8 height and 7 length? Because the water will overflow from here. You only have to take that much height, whichever the lower bar is set at. If there is a left bar at 8 height, right bar at 7 height, you cannot take the water at 8 height because water will overflow from here. So although it is not mentioned in the question that we have to take care about overflow, but it is self-explanatory that we have to only take the height between the bars. It should be mentioned somewhere. It is between the bars. Find the two lines which together forms with the x-axis a container. So container means the water cannot overflow. Container means the height of the container should be equal to the water height. So how we can actually solve this, how we can figure out the two bars or two vertical lines which will form together a container. See, a brute force solution can be to figure out all such pairs of bars. Brute force will be find first bar, and then after finding first bar, find the second bar. Find all pairs of bar. Example is, if I am taking first bar as the height 1, if I'm taking second bar as height 8, what is the amount of water I can store? I can only store amount of water with height 1 only. And what about length? The length will be 1. Why? The distance between 1 and 0 will be 1 minus 0. It will be 1. So 1 into 1, what is the maximum amount of water till now? The maximum amount, or you can say answer, will be 0 initially, and now it is 1. 1 into 1, to be precise. Then, if the first bar is 1, second bar is 6. Again, what is the maximum height? I can only store 1 only. Why? Because the water will overflow if I will make the height increase from 1. And what will be the length? Length will be 2 minus 0, which will be 2. So 2 into 1, it is better. So update the answer. Then what about this one? Along with this one, it will be again 1 into 3. So 1 into 3 will be 1 better. Then 1 into 4, then 1 into 5, then 1 into 6. If I am taking the second height at this. Even though the second height is 8, but I can still take the height of water as 1 only, the minimum height only. 1 into 7, and finally 1 into 8. Maximum will actually go as 1 into 8 if the first bar is taken as 1 height. What if the first bar is taken as the height 8? In that case, if the second bar is taken as height 6, what is the amount of water I can store in between them? The height will be 6 only, the minimum of them, and the length will be the distance between them, that is 2 minus 1. What is the formula? The formula of area will be, let's say the left bar is left, L. Let's say the right bar is right, R. Let's say for now I'm taking this as left, this as R. What is the amount of water which I can store between them? I can say the height of water between them will be the minimum of L of R. The minimum of L comma R. And what will be the length between them? The length between them will be the distance between those two bars. That is the indices, the difference between the indices. So L and R will be the values actually. So we can say array of L comma array of R. The minimum height into the distance, and distance will be R minus left. That is R minus L. That is 5, 5 value having fourth index, 6 value having second index. So 8, 4 minus 2, which is actually not 8 but 2. 4 minus 2 is 2. That is the distance between them is 2. And what will be the height? The height will be the minimum of 6 comma 5. The value is minimum, the height's minimum. So minimum will be 5. So if I take the left bar as height 6, right bar as height 5 with distance 2, the amount of water I can store between them will be 2 into 5, which is 10. And this way I will figure out all such pairs. So what will be the maximum pair according to the question? According to the question, the maximum pair will be nothing but the height with left height at 8, right height at 7. Why? Why not right height at 8 only? Because only increasing the height will not increase the area. Increasing the length also will increase the area. Not only this, but this also will increase. It will result in increasing the area and hence increasing the amount of water. So if I take these two pairs, these two elements in the pair, what will be the distance between them? It will be 8 minus 1, 7. And what will be the minimum of 7 comma 8? It will be 7. So it will be 7 into 7. That is what the maximum is. But if I would have taken this bar as a right height, this bar as a left height, so minimum of 8 comma 8 will be 8 only. If you can store 8 amount of water, 8 height of water actually, what will be the distance between them? 6 minus 1, only 5. So 5 into 8 will be 40. So 49 is better than 40. So I will take 49 only. So that's why the strategy is not only increasing the height. Obviously, height increasing is one thing, but the strategy is also increasing the distance between them. So that was the brute force solution. What will be the time complexity of brute force? As you can clearly see that I will take the first element, then second element as all the bars remaining, then first element as a second bar, remaining all the bars as second bar. That is nested loop. So nested loop will require order of n square time complexity. 2 loops will be required, n square time. What about space? It will actually not require any extra space because we can just maintain the answer variable as an integer and figure out all such pairs. But the question is, can we do it better? And the answer is yes, we can do it better. See, What is the objective? The objective, as you can clearly see, is increasing the area. We want the maximum area. But in order to increase the area, we can increase the length or we can increase the height. Length into height, if we are saying, and breadth we are taking as one, or we can say width we are taking as one only, negligible. So in order to increase area, we are increasing length or height. Height is not in our control. Why? Because height is given in the array already. But what is in our control? It can be the length. What we can do? We can try to take the maximum distant apart bars, the bars with the most distance. So initially, what I will assume? I will assume the first bar, the left bar which I am taking is at the 0th index. The right bar which I am taking is at the 8th index. That is the two bars with the maximum distance. Why it will help me? If I will take the maximum distance, the area will increase. It might be having lesser height, example, one height only. But I will try to improve it in terms of height. First, I have taken the maximum length, although the height might be the minimum, but I will try to balance both. I will try to go to a certain point where length will also be good enough, height will also be good enough, and the area will also be good enough. That is the maximum. So currently, what is the area? Currently area will be 8 minus 0 as the distance, 8 minus 0 as the distance, and the height will be minimum of 7 comma 1. What is minimum of 1 comma 7 or 7 comma 1? It will be 1 only. You can only store one height. So 1 into 7, 1 into actually 8 will be how much? 8 into 1 will be 8 only. So for now, the maximum area will be 8. The answer variable initially will be 0 and I will update it to 8 because current height is 8. But now I should try to optimize with the height. I should try to increase the height. If I want to try to increase the height, should I discard the height 1 or should I discard the height 7? This is a very good question actually. See, what will happen? If I am saying the height 1, if I am taking the same, left bar I am taking the same. If I am making the right bar go to the previous bar, I am decreasing the height because I am decreasing the distance because I want to increase the height. If I want to increase the height, I have to decrease the distance. That is why I am making both the pointers shifted towards each other. So if I will make the right pointer go to the previous index, the right pointer is having height 3, but the left pointer is still having height 1. What will be the minimum? Minimum will be 1 comma 3. It will be 1 only. So no change in the area. There will be no change in the area if I will discard the right value, that is higher height. If I will discard higher height and keep the smaller height as it is, do not discard it. The area will remain same. Why? Because the constraint is on the smaller height only. Even if I take the pair 1 comma 3, the distance will decrease. Also, the height will remain same. So overall area will increase. The height will remain same. Why? Minimum of 1 comma 3 will be 1 again. Minimum of 1 comma 7 was also 1. 1 comma 3 will also be 1. So no need to discard the higher height. Better will be to discard the smaller height, so that there might be a chance where the height is increased. So in order to decrease the smaller height, currently the smaller height was on the left because it was 1, it was 7. So better to discard the smaller height and make left plus plus. Although distance will decrease, but there is a chance of height getting increased. What is the area now? Area will be 8 minus 1, that is the length, the distance between the bar, into the minimum of 8 comma 7, and minimum of 8 comma 7 will be 7 only. So 7 into 7 will be 49, and that is what the maximum was. So although I will try to find out more such pairs, we will not be able to, but let's do what? Let's just change one of the values. Let's just make this also as 8 height. And let's try again. So in that case, there might be a scenario where 7 minus 1 is 6. 6 into 7. Actually, 6 into 7 will not give me distance, which is better than 49. But let's do what? Let's make it 9. It might be giving me better height. Let's make it 9. If this is 9 instead of 3, what will happen? Let's see. I am saying what? Left is having height 8. Right is having height 7. Should I discard the left height or should I discard the right height? The question is, if left height is discarded, will I get any benefit? The answer is no. Even if I make the 8 height become 100, even if the next height was 100, there will be a minimum of 7 comma 100 as 7 only. The lower height is what is determining the answer, determining the overall height of water. Minimum of 8 comma 7 was 7. Minimum of 100 comma 7 will also be 7. Minimum of 6 comma 7 will also be 7. So better will be not to discard the higher height. Again, discard the smaller height. And in this case now, smaller height is on the right side. Previous case, smaller height was on the left. Now, in this case, smaller height is on the right side. So I will discard the smaller height. And how can I discard the right side height? By making right minus minus. What is the current possible pair answer? It will be distance 7 minus 1 and the height is minimum of 8 comma 9. Minimum of 8 comma 9 will be 8 only. So 6 into 8, what is the distance? What is the overall area? Area is 48. It is not better than 49, so we will not update the answer, but still, what should I do again? Should I discard the 8 height or should I discard 9 height? Will discarding 9 height give any benefit? No. Actually, discarding the higher height will not give any benefit. Discarding the smaller height might give a benefit. Might not be, but might give. So now what is the area? Area will be 7 minus 2. 7 minus 2. That is the distance. Into minimum of 6 comma 9. So minimum of 6 comma 9 will be 6 only. So 5 into 6, very less height, only 30, like not better than the previous height. Again, discard the smaller one. That is, discard the left height. I will do left plus plus. Left initially was at 0. Then it came at 1. Similarly, right initially was at last index. Now it is at 7th index. 2 comma 9. Minimum will be 2. Distance will be 7 minus 3, 4. 4 into 2 will be only 8. Like no better answer. So this way we will keep on doing the work till obviously the distance between the bars is 0. Or you can say both the bars become same. Or till the point left pointer is smaller than right pointer. Till only that point we will run the loop, and as soon as it is done, we will stop. So since we were able to increase the length as well as height together, how length? We first took the distance farthest points, that is leftmost and the rightmost point, that is farthest distance. And we tried to increase the height also by discarding the smaller height value. If left was having smaller height value, left was discarded. If right was having smaller height value, right was discarded. So this was the two-pointer technique. What will be the overall time complexity of this approach? Since we only require two pointer, one pointer from left to right, another pointer from right to left, either of the pointers are moving, and in total, both pointers will meet at certain points. That is, they will traverse the entire array together. So it will be order of n time complexity. What about space? We will not require any extra space. Only answer variable 4 bytes is required. So constant space. So linear time constant space solution, a very optimized solution, better than the brute force which we discussed. Now we will be doing the instruction manual, milestone number 3. We are done with the second milestone. So first line as already written is initialize a answer integer as 0. Integer as 0. And finally, obviously, return the answer. It is already written in Java. It might be written in other languages also, but we have to initialize the answer, the maximum area is 0, and return whatever the maximum area finally will be. We have to consider two pointers, initialize two pointers, or maybe you can say set left as 0 and right as n minus 1, where n is the array dot length. It is self-explanatory. We have to run this two pointer till the point what? Till the point left is smaller than right. So run a loop till left is smaller than right. Left is smaller than right. What we have to do inside the loop? We have to check what is the area right now. So set area as what? Set area as the formula which we discussed, that is minimum of the array of left, or you can say the height at left, comma the height at right, the minimum of the heights into the distance between them. And what will be the distance? The distance between right and left bars will be right minus left. That is a positive distance. So set the area as the minimum height into the distance. Check if this is the maximum area or not. So we can say answer will be set answer as the maximum of answer till now, of the current answer, or the current height, or the current area, you can say, not the height, but area. Whatever is maximum. The current answer till now, that is 0, 0, where is the dry run? 0 versus 8, 8 is better. 8 versus 49, 49 is better. 49 versus 48, 49 is better. So whatever is better, store that. And what we have to do, if the left height is smaller, if the height of left is smaller than height of right, we have to discard the smaller height. So discarding smaller height means we have to do left plus plus in this case. Then do left plus plus. Otherwise, if right height is smaller, so how we can discard the right height? We can make it go to the leftwards, that is right minus minus. So this will be a simple two-pointer logic in linear time complexity. That was all about the third milestone. We will code the instruction manual, that is convert the code in, write the code in Java actually, and also figure out some corner cases if there are any, and time and space complexity. So we have already initialized the answer as 0, which will require us to basically calculate the maximum area. We will initialize 2 pointers, left as 0, right as array dot length minus 1, n minus 1. And we will run this 2 pointer logic only till the point the left pointer is smaller than right pointer. Why? Because as soon as left becomes equal to right, the distance between the left and right will become 0. Or as soon as the left pointer becomes more than right, the distance will become negative. So no need to take negative distance. So what will be the area? As discussed in the approach video, the area will be the minimum of the left height comma right height. First take the height as the minimum. Why? Because if I will take the maximum, the water will overflow. So we have to take the smaller bar as the height reference. And the distance between them will be right minus left. Keep on doing this area, calculating the area and storing the maximum. So answer will be the maximum of the answer till now and the area, current area. After setting the area, we have to update the left pointer or the right pointer accordingly. If left height is smaller, then left should be discarded. So if height of left is smaller than height of right, we can discard the left value by making the left pointer plus plus, because left pointer is going towards the right side. Otherwise, we have to discard the right pointer by making right pointer minus minus. The code is complete. Let's run the code and see what is the output which we are getting, and then we will see if there is any corner case or not. So it is taking some time. For the sample input, it is giving me 21 for this input. Let's take the sample input, one more sample input actually, and let's just run it to see if it is going to give me 49 or not. It should give me 49. Let's see. And it is taking some time to run actually, and it is giving me 49. Let's do what? Let's just print the area to see if what we were getting in the dry run is what we are getting in the output also. And in the dry run, we changed the height 3 with height 9. Let's see. It should give me actually height 8, 49, 48, 30, and so on. These should be the areas actually, not the heights, but areas. 8, 49, 48, 30, and so on. Yes, it is giving me the same height, and it is updating correctly as thought. So let's just remove the debugging line and let's just submit it. So we have already discussed the time and space complexity in the approach video. What was the time? Since we are running a simple 1D loop where every time either left plus plus or right minus minus is happening, a linear time complexity will be required. And since we are not taking any extra data structure, any auxiliary data structure, constant space will be required. So linear time, constant space, order of n time, order of 1 space will be required. That was all about the problem. Determine the capacity of the largest container. We have coded it. So with that, we have done the fourth and fifth milestone. We will meet in the next video where we will discuss a new problem. Till then, bye bye. Take care.